Hey everybody, welcome to today's Kubernetes Masterclass. Really excited for today's session. And we do these every Tuesday, and we have a special topic today, load balancing with Kubernetes. We're right at the beginning, and we have a lot of people joining the line as usual. We have just a huge number of registrants and expect a lot of people to be attending as well. I do want to let everyone know as people are joining the line that this session is being recorded, and you will receive, following the training in your email, the recording as well as the slides. So if you miss anything, if you need to leave early, and anything like that, don't worry about it. You will get follow-up after the session. Just look for it in your email. As a way of introduction, my name is Matthew Shear. I'm a marketing manager with Rancher. I host some of these training sessions as well as the intro to Kubernetes and Rancher training sessions on Thursday, every Thursday, totally free. You should check them out if you are a new user to Rancher or to Kubernetes. And our presenter on the line, who will really be doing the heavy lifting on this session, is Murali. Murali, are you there?
Yes. Hello, everyone.
All right, awesome. So both of us have our contact information on the slide. Feel free to continue the conversation, reach out to us after the session, if things come up, and you will be able to reach me at Twitter or email, and Murali at Git or Twitter. A couple other housekeeping items before we dive into the heart of the material. We try to keep the topic to 40 to 45 minutes. I think we will go long today, which is okay. We actually have 90 minutes scheduled for the session. If we need to take some more time, it's okay. Please ask your questions. Questions are absolutely welcome. This is meant to be educational, it's class atmosphere. So ask questions at any skill level, and we will do our best to respond. GoToWebinar has a really cool feature to ask questions where you can place them directly in the chat. If for whatever reason you want your question to be private, please mark it as such. Otherwise, when we respond, we will usually respond to everyone so they can see the question and the answer for the benefit of all. We'll also take moments during the training to pause and answer some pertinent questions to the material, and then we'll leave time at the end to just get through as many questions as we can. So if you have questions on load balancing, go ahead and start asking them. As I said, this session is being recorded, and so are our other classes. We do these master classes on various topics almost every Tuesday, at least 2 to 3 times a month. And you can find them all on YouTube. You can also find them on our rancher.com Kubernetes Masterclass page. If you just scroll to the bottom, you will see past classes. You'll be able to download the recordings and the slides, always free and always live. If you go to youtube.com/c/rancher, then you will see all of our online meetups and our trainings like this one there for you to see as well. You can also join us on Slack to continue the conversation and participate in the really awesome community that we have with Rancher. If you go to slack.rancher.io, you can join there for free, ask your questions, and hundreds of people are on there every day answering and asking. For these trainings in particular, we use Pound Masterclass for the channel. You can see announcements. Sometimes presenters have additional files or what have you that they'll post there as well. So be sure to join that channel for future training and just get the conversation going. We also love hearing from people on Twitter. It's just great to find out how this class goes for you. And of course, if you do have questions for Murali or myself, do use the GoToWebinar control panel because we will not be checking Slack during this session, though we might look afterward. Also, as I mentioned, there are great upcoming classes, and we have these scheduled through August at this point. Next week, we'll be hosting Wizards of the Coast engineers, where they'll talk about their production multi-cluster deployment. It should be awesome. Obviously, I'm a huge Magic the Gathering fan, so I'm super excited to see what they have on the operations side. And just a lot of cool sessions coming up on Istio, on security and such. So it's really good. I also wanted to mention an ebook that is also free, deep diving with Kubernetes networking, that Murali co-wrote with another Rancher engineer. That is a way to get even more material and more in depth. I think it's almost 50 pages, if not more. So it is another resource to the deep end of the pool with this material. So at this point, I am going to pass the presentation over to you, Murali, so we can actually get going with the topic today. So I'm passing the presentation over to you.
Cool.
And okay, I can see your screen.
Okay, cool. Hello, everyone. My name is Murali Paluru. I'm a principal software engineer here at Rancher Labs. Today, I'm going to talk about load balancing, especially how we do load balancing in Kubernetes. So here is the agenda for today's talk. We will understand, what a load balancer is and why one would need a load balancer, and we'll go over the different types of load balancers from a networking perspective, and we will cover the different types of load balancer options that are available in Kubernetes. We'll go over each one of them in detail, and then we will have demos all along the way. And if you have any questions, as Matthew mentioned, please feel free to ask them in the webinar, in the GoToWebinar, and and also we will pause in between to take questions. And once the presentation is done, I will upload all the code snippets that I have used in this presentation in this particular GitHub repository. All right, so let's take the scenario, like why are we all attending this webinar? Maybe you have a cool idea, or you are already working on a cool idea. We are all interested in making this world a better place. So let's say you have built an awesome application and you have launched it either in the cloud or in a data center or within your organization or within your enterprise, and then you have your initial users started using your application, and then you have built such an awesome app that it became a viral sensation and you have lots of users. And now you have a problem. Your load balancer, your server is not capable to handle so many users. So you have a problem. So what do we do? So the next thing that we do is, we increase the number of servers that can serve the increasing demand from the users. And we use a device called load balancer in front of these servers, which can distribute the traffic to these various backend servers. So, a load balancer is nothing but a device which could be either physical or virtual that can distribute your incoming network traffic across your different backend servers, which are part of a cluster. Now, after your app became successful, your users started requesting for more security. So the first primary request is, hey, can you make your app use SSL certificates? So you go fetch your SSL certificates from let's say Let's Encrypt or some other CA, and then you have to install these certificates on all of your backend servers. After you do that, you will realize that either the SSL is taking too much of overhead on each of these backend servers, or you might find that it's becoming difficult to manage these certificates on all of these backend servers. So the load balancers have a functionality inbuilt to them where they can do SSL termination on the load balancer itself. So that way your backend servers can just focus on serving your application and not worry about SSL termination. And let's say you in your application, you have a request for some cool feature. You have built this cool feature, and also let's say there are like few small minor bugs that you wanted to fix. So you have done all those things. You have a new version of the app that you want to deploy. So how do you do that? You can take the advantage of the load balancer. You can do version upgrades of your app, which is on your backend servers, one after the other. And the load balancer is intelligent enough to take care of the downtime of a particular server, and then bringing the server back up once the new version is running. And you can do a lot of intelligent traffic engineering, traffic control. You can specify different rules and stuff like that. So it can help in, load balancer can help in version upgrades. And there are other applications of load balancers. For example, there are web hosting companies which help different users launch their apps on their infrastructure. And a load balancer can provide this domain name routing for the different users. So to summarize, load balancer can do multiple things. Like it can do load distribution, SSL offloading, it can help you in version upgrades, and it can take care of routing. Any questions so far, Matthew?
Oh yeah, there are a few. Now, one is if you could paste into the chat the Git repo that you mentioned in one of your first slides, so that people can see it while you're doing your demonstrations.
Oh, I did not upload the manifest files yet, so I will do that at the end of the presentation.
Okay, cool. Awesome, thank you. The other questions are a little bit more specific to Rancher. You want me to just read them so you can keep them in mind
as
you go? So the first one is, I've set up load balancing as per the instructions for Rancher and don't actually know how to verify its function.
Got it. We will cover that.
Okay, cool. Another one is, I've set up an Ingress load balancer, which is active, has an active status, but when I click the link, it's a 404.
Okay.
And let's see, would you use Istio or Ingress for load balancing an Ingress or Y? And will you cover any plans for Rancher integration with Metal LB for on-premise load balancing? And that's it so far.
Okay, cool. I will answer as we go along. There are many varieties of load balancers that are out there. Some of them are open source, some of them are closed source, some of them are virtual, and some of them have physical hardware like F5, Avi, Cisco, and there are many other companies. And some of the most popular software load balancers are HAProxy and Nginx. There are, from a networking perspective, there are like two major types of load balancers. You will often hear this word L4 or layer 4 and also layer 7. It's also called application load balancer. What exactly does it mean, right? Before we can answer that, let's just quickly take a look at a networking packet. So let's say if I see this picture from the top, on the right side, I see there is a user data, which is on a computer. Let's say you're trying to access a website, or you're trying to send an email, things like that. When you access a website, the traffic or that data is sent down into the computer's software kernel, and it goes through this chain of layers, where each layer keeps adding more information to the user data. Now, the topmost layer, it's called the application layer, or layer 7, and the next layer below that, it's called a transport layer. So or layer 4. At layer 4, generally we are talking about these two popular protocols called TCP and UDP. And below that we have IP and Ethernet, and you have the actual physical devices. How you transmit the data, is it wireless or Ethernet, optical, whatever. So layer 2 deals with how do I send the packet from one node to another, and in a particular local area network or in a LAN. And then you have this IP, which is responsible for sending packets across different networks. And the layer 4 is responsible for delivering the packets on a particular device on various port numbers or various protocols, and finally the application data. So when you hear layer 4, what it means is these load balancers are inspecting the network traffic at the layer 4 or until layer 4. That means they can read all the information all the way up to the TCP/UDP headers. A layer 4 load balancer cannot look into your application data. Now, in case of a layer 7, it's even more intelligent. It can inspect your application data. And when you hear layer 7 app load balancer, generally we are talking about either HTTP or HTTPS. So, let's say you have a website traffic, it's HTTP traffic. So a layer 7 load balancer can inspect that data, and it can make intelligent decisions based on the content which is there in this packet. So that's the different load balancer types from a networking perspective. Here is an example of the two type of load balancers in AWS. You have the app load balancer, which is layer 7, which is on the left hand side, and then you have the network load balancer, which is layer 4. Cool. So now let's talk about how load balancing happens in Kubernetes, why we need it, and things like that. All right. So here in this picture, I'm trying to show the different nodes of a Kubernetes cluster. And when you have a Kubernetes cluster, there are like many pods running in it, a lot of system services. And one of the interesting part that I want to talk about is the DNS part. So a DNS part running on a Kubernetes cluster is responsible for service discovery within the cluster. So let's say you have these different application pods which are running, and they want to discover other services. Let's say you have app 1 or app 2. So app 1 can talk to app 2 by just using app 1 name. So the name resolution is done by the DNS part. As the load of your apps, as the number of pods on your cluster increases, you have the same kind of problem that we saw earlier, where your single DNS pod is not able to handle all the DNS requests that are coming in. So what you do is you scale up your DNS pods and you distribute your load across that. So how we do that is using a Kubernetes concept called cluster IP. So this is one of the native load balancer concepts which are available in Kubernetes. So a cluster IP does help with load distribution, and it also helps with version upgrades. And from the networking perspective, a cluster IP can function only up to layer 4, which means it can inspect network traffic only up to TCP or UDP headers. It is internal to the cluster. What I mean by that is this particular type of load balancer is available for use within the cluster itself. Nothing outside the cluster can access this cluster IP. So how do we configure this cluster IP? Using a Kubernetes service. It's a type of a Kubernetes service. This LV also provides service discovery using the name of the service. And the interesting thing is there are no network interfaces associated with the cluster IP, unlike the other IP addresses that we generally see. So when a Kubernetes cluster is brought up, we have this component called Kube API server. So one of the arguments that you can pass to this Kube API server is the cluster IP range. You pass a subnet to this using this argument to the Kube API server. So when you create a cluster IP in your Kubernetes cluster, the IP address is randomly picked from this particular subnet. And I have a few interesting notes here. If you are trying to expose your application inside a Kubernetes cluster, always use a cluster IP. Please do not rely on pod IP addresses, because pods and their IP addresses are ephemeral. What it means is, like, let's say you have a simple web application running in Kubernetes cluster, and there is another downstream application which is relying upon this web app, which is a microservice. If you use the pod IP, let's say the pod dies and the pod is recreated on a different node with a different IP address, then how is the downstream app going to work? It's going to have a downtime. So please do not use pod IP addresses. Always use a cluster IP if you are trying to expose your application within the Kubernetes cluster. As part of the cluster IP, you get this service discovery by default in Kubernetes. What it means is, let's say you create a service, you specify a name to the service. Let's say I have a database. I could name the service as DB. So apps, other applications which are running in the same namespace of this cluster, or they can access this service using just the service name. So if your name of the service is DB, you can access DB colon, let's say if it is MySQL 3306 or whatever port you have used to expose the service. And if you're using a service from a different namespace, you just append .namespace. And if you want to use the full FQDN, it looks like this, like service name .namespace name .svc .cluster .local. All right, so how do we create a cluster IP? Well, so there are multiple multiple objects that you can use to deploy your applications. One of them is a deployment. So here, let's say I have created a deployment, and the next thing that I would do is I create a service object. So this is so on the left-hand side, you can see this is how a service object looks like. This is the manifest file. Here you can see the type of the service is cluster IP, and the name of the service is alpha. So what it means is, if I want to access this microservice, I could just say, telnet alpha 9091 or curl alpha 91 colon 91. And how are these two different objects linked together, right? So if you look on the right-hand side, you have labels specified in your deployment, and you use selector labels in the service, which is on the left-hand side here. You specify the selector label, and that's how a particular service can target a particular deployment. And a deployment here is exposing port 9001 inside the container, and your service is targeting 9001. And then you have this field called port. What it means is, you can use a different port on your service to expose your underlying app. So here 9001 is the port used by the app inside the container. So when you do netstat, you will see the process is listening on 9001, but using the service, you can map this to a different port. Here in this example, I've used 91. And if your clients inside your cluster, I call them as internal clients, if they want to access your application, they use the name of alpha and they use the port 91 to access it. All right, so for the cluster IP demo, I know we will have a simple Kubernetes cluster, and we will launch a daemon set, which is a kind of simulating an internal client of my cluster. And then we are going to launch a deployment of one pod, and then we will create a service for that. After we do that, we will try to access this service using the cluster IP. And after we are done with that, we will scale it up to 4 and see how the load balancing is actually working. And we will also see how the version upgrades are done, and we can see the upgrades in action as well. For this demo purposes, I'm using my image. It's called Swiss Army knife, leo.cloud/Swiss Army knife. Well, what it does is it runs a single Go binary that acts as a web server on a given port. What it does is it renders a simple web page, for the NATO alphabets, and it also displays the host name and the IP address of the container, which is useful when we are trying to understand these concepts. And also it has all the tools needed for debugging purposes. And when you launch this sample app, you have two environment variables which can allow you to customize this how this app runs. Like you can change the port on which this app is running by passing the value in the port environment variable, and you can specify which alphabet to show in the web page when we are rendering. We will just see it in a moment. All right. Any questions related to the topics that we have covered so far, Matthew?
Yeah. So one from Basir asks, can you change the size of the cluster IP range on the fly?
Let me just let me see if I can do that. Okay, hope that helps.
And then Daksh asks, can the app that is running on a different node access the database running on a different node, but in the same Kubernetes cluster?
Yes, it can. If the database is exposed using a service. Okay, if there are no more questions.
Go ahead.
Okay, cool. So in the interest of time, I have created a cluster already for our demo purposes, and this is the UI of Rancher. I am on the global page where you can see a list of your clusters. As you can see, I have created RKE cluster on the AWS cloud. If you want, you could create multiple other clusters. You could use the managed Kubernetes services from various cloud providers, or you can create your RKE clusters using the various cloud providers, or you can create your custom cluster from your in-house data center worker nodes, and you can import an existing cluster as well. So, for more information, you can check out Rancher or our other classes from the past, and we also have like monthly Kubernetes training. You can get more information there. All right, so let's get started with the demo. So in this cluster, I am switching to the default project. So project is a Rancher concept. What it does is it's a grouping of multiple namespaces. A namespace is a Kubernetes native Kubernetes concept. A namespace has been built as a building block to enable multi-tenancy in a Kubernetes cluster. What it means is you have this huge cluster of, like, let's say 10 nodes, 100 nodes, 1,000 nodes. You want to provide access to this cluster in a secure way for different users. So you gotta have a logical isolation. So namespace is the building block which allows the administrators to provide multi-tenancy, to provide access to this cluster to different users. All right, so in this project, let me deploy an application. Let's call it Alpha, and then I'm using my image, and I'm deploying it to the default namespace here. Here I'm going to use the container port 9001, and I want to use the cluster IP. So I can select the cluster IP, and here you can change the listening port of your service. So here, let's change it to 91. And in the environment variables, I'm specifying, hey, use the port 9001 to serve the web server inside your container, and please show only letter A in the application. And I'm just verifying, yes, this looks good. Let me launch this workload. All right, cool. So the workload is launched. So if I click on this workload, here you can see the parts which are part of this workload. So here you can see there is a pod that has been launched. Here is the IP address of this pod, and it is running on this particular node. So we can execute shell inside this container, and let's just see what's happening. All right, here is my simple Go binary, which is running here on process ID 1. Let's run netstat. Here you can see my application is running on port 9001 as we specified. Let's just exit from here. All right. Now, how do we access this application? If you remember, we wanted to deploy a client application which is simulating, internal clients. So let's just do that. Let's go back to the project and then deploy. This is my internal client, and I want to deploy one part on each node of this cluster, and I want to use the same image, and then I'm not gonna customize it this time, and then I launch it. So this is when you are trying to launch one part per node, the concept or the underlying object that is used is called a daemon set. So we have a daemon set created here, and as you can see, there are like 3 worker nodes present in this cluster, and there are 3 parts which are launched here. And we can execute shell into these container into these parts. Let's just go here. We can see these parts are running on different nodes. Execute shell, and here I can do curl HTTP. I can specify the name of the service that we created earlier. It was alpha, and the port that was used was 91. Cool. Here we can see, the host name of the container is alpha blah blah blah, and the IP address is 10.42.3.4. How do we verify this, right? So let me just open another tab here, and let me switch to the default project and jump to this particular alpha part and go inside this shell, and then let me check the IP address. Here we go, 10.42.3.4. That's the IP address of the pod. The next thing that I want to do is close this shell, and I want to scale up this particular application. 1, 2, 3. All right, so I have scaled up the application to 4 parts. As you can see, new parts are being started, and if I click on this part, hey, there are 4 parts running, and here are the IP addresses. Cool, so we don't have to execute shell to find out the IP addresses. So here are the IP addresses. Now let's just jump back to the internal client that we have and do a curl of this one here. Let me try it one more time. All right, as you can see, the requests are being served by the different parts. So you can see the load balancing happening in action here. The first time the request hit this particular container with this IP address, and this is a different part, and this one is a different part. So this is how the load balancing is done. So underneath the covers, Kubernetes could be using IP tables. It could be using some other components as kubeproxy to do this load balancing. All right. So before we change or explore the version upgrades, I want to run this in a loop so that you can see what's happening, right? So grep, and then I want to just print the host name, and then I want to print only the IP address. All right, so that's the host name and the IP address, and I want to do this in a loop. All right, is it working? Cool. All right, so while this is going on, what we want to do is, okay, maybe let me not grep because I want to show the version upgrade. So let's just get rid of this grep here. All right, so now this application, as you can see, it's displaying A for alpha. Now, if I edit this workload and then change it to a new version, right? I'm simulating the change of version by just changing the alphabet here, and I click on upgrade. As you can see, the upgrades are happening right now. While that is happening, you can see the load balancer is still serving, and you can see one of them is B for Bravo. So as the backends are being switched out, the load balancer is intelligent enough to figure out, hey, one of the parts is down, I need to stop sending traffic to this particular part, and once the new part comes up, I need to start diverting all the traffic to the new ones that are coming up. And after the whole upgrade is done, as you can see here, the load balancer intelligently figured out that it needs to do the switching, and it has done. And now we can see everything is B for Bravo. So that's the demo for version upgrades using cluster IP. Let me do a Control C, and let me just roll back to the previous version. As you can see, you can change, you can roll back into the past very easily from Rancher. And while that's happening, let's just check it again. You can see B for Bravo, and then you can see A for Alpha. And finally, after a couple of seconds, everything will be served using the previous version of the application. All right, so that ends the demo for cluster IP.
Hey, oh, good timing. I was just about to ask a question. Actually, going back to what Visar had asked, a couple people pointed out on the question about cluster IP range. He actually meant not changing the font on the PowerPoint, but how do you can you change the cluster IP range? When Kubernetes is running, the block of IPs used.
No, I do not think you can change the cluster IP range on the fly when a cluster is running. You have to plan for your cluster IP range when you are about to create the cluster. Anything to do with networking, it's generally it's kind of static in some ways, because there are a lot of underlying things involved. It's just not so easy to just switch out or swap out certain things. Now I keep hearing these questions, hey, can I change the IP address range of the parts? No, I mean it's kind of hard. It's not doable at this point. It's possible probably theoretically, but at this point in time you cannot do that in a Kubernetes cluster. You cannot swap out the range in a running Kubernetes cluster. You have to plan ahead of time and then use it when you're creating the cluster. And you can change it when you can specify it when you're creating the cluster. For example, here, add cluster, and I think, let's say, you go to advanced options, or I think probably edit as YAML. Yeah, in the edit as YAML, here you can see you can pass the service IP range, and this is for the Kube API. Yeah, this is the service IP range. This is how you can change it. And the cluster seeder is the pod seeder. So you can change it when you're about to create a cluster, not afterwards.
Cool. Okay, thank you. Awesome. Here's another one. This what just came in from Victor, who asks, how do I control, or can I control, the upgrade balancing strategy? For example, I want to start serving a new version if it will go up to 3 pods.
I believe there are upgrade strategies available. There are multiple configuration options available. If you go look up Kubernetes documentation, you should be able to find that information. I do not know on top of my head, but I know there are like some parameters available, some knobs available, which can help you control this thing in Kubernetes.
Cool. Okay. One more, and then we can go on. This one's from Rajiv, who asks, so what is the default load balancing algorithm that Kubernetes uses? Is there any way to extend this?
Okay, that's a good question. I do not know on top of my head. I have to look up the documentation to answer that. But please go to kubernetes.io, and if you go to the documentation, I am sure you will be able to find the answer that you're looking for your question. But I do not know on top of my head.
Okay, awesome. There are other questions, but I think they're a little bit more relevant when they asked about Metal LB and Envoy and stuff, and then
Okay.
more relevant later down the road.
Okay, sounds good. Cool. So we just looked at how cluster IP works in Kubernetes. All right. So the next kind of load balancing option that is available in Kubernetes, it's a type of service, and it is called NodePort. So if you remember in the previous slides, I talked about internal client. I specified that cluster IP is accessible only from within the cluster. Now, what if I want to expose my app outside of my cluster? For servers or laptops running outside of the cluster. How do we do that? So NodePort is one of the options. So NodePort does layer 4 load balancing. It provides the same kind of load distribution and version upgrades, and it is exposed outside using a port or ports on all of the nodes. So what it means is, let's say you decide to expose one application, and you ask Kubernetes to expose it as NodePort. There is a NodePort range that you can choose from when you're creating the cluster. Just like the service IP, you specify the port range. This is the default one, 30,000 to 32,767. Kubernetes, you can either pick one of the ports from this range, and Kubernetes will allocate that to you if it is available, or you can let Kubernetes assign a random port to you. Under the hood, what NodePort, NodePort also uses cluster IP for the actual load balancing purposes. And unlike cluster IP, there is no service discovery for this NodePort. We will see that in a moment. And the good thing about NodePort is, it can be accessed from outside of the cluster. And if the node IPs are public, you can access it over the internet, or let's say you have a direct connect to your cluster from somewhere else. You can access this NodePort application behind this NodePort, or if you have a VPN and things like that. There are a lot of underlying networking setups that allow you to access these apps running inside your cluster. But the core concept is NodePort. All right. So just like a cluster IP, we have an app. In this example, I call it Bravo, and I have a service which looks very similar to the cluster IP. The main difference is line number 8. We specify the type of the service is called a NodePort, and here in line 11, I specified, hey, I want the NodePort. Let me pick the NodePort 32,092. If that port is available, Kubernetes will give that to me. Otherwise, it will give something, some random port. Even if I don't specify this node port, I will get a random port allocated by Kubernetes. And how are these connected? Just like cluster IP, we have the label selectors working from service to the deployment using the green arrows, and then we can see the target port and the container port linked via the red line, and the internal clients can still access this particular service via the service name and the port. And the interesting thing here is, like, the external clients now can access this application using IP address of one of the nodes and the node port that has been assigned. So that's how the external clients access it. So for the NodePort demo, we have the same Kubernetes cluster. We'll deploy a different application. Here, let's call it Bravo, and then we have an external client, which is my laptop, and my cluster is running somewhere in the cloud, and the node IP addresses are public, so I can access it from the internet. And then we will scale up the pod. No, we will not scale up the pod. That's homework for you. So, the same kind of scenario that we did earlier, you can try it out yourself. Before we get on to the demo, any questions?
There is a NodePort question here, which is from Zach, who asks, I've read online that NodePort should be avoided in operations. We're planning to use Ingress to route external traffic to our Kubernetes clusters. What are the benefits and features that NodePort provides that Ingress does not?
Excellent question. So an Ingress, that's the next one of the topics that I'm going to talk about. Just to answer this question in this context, an Ingress can work only with HTTP or HTTPS traffic. Now, if you want to expose an application which is not a HTTP or a HTTPS application, basically it's not a web application. Let's say you have a database, a MySQL database, or you have a MongoDB that you're running inside a cluster, but you want to expose it outside of the cluster. In that scenario, an Ingress is not going to solve your problem. You need to have a NodePort running to be able to expose that application. So this is one of the perfect examples where you would have to pick NodePort. And if it is a web application, probably, most likely it makes sense to use an Ingress. Okay. Any other questions?
Yeah, none on NodePort, so keep going.
Okay, cool. So let's jump on to the demo. So let me pick the cluster. Let me switch to the default project. And here, let me deploy a different application called Bravo. I want to run one pod. I'm going to use the same IP. And here, I'm going to use 9002. And here you can see I'm selecting NodePort. And here I'm leaving it up to the Kubernetes orchestration to give a random port, or if I want, I could have clicked this and then asked for a port. So in this case, let me ask for a port. I don't remember what I wanted to choose. Okay, I wanted to choose 32092, 32092, and then the environment variables. I want to run my app on 9002, and here I want to specify, hey, show only B, and then launch it. Cool. So here, you can see the pod has been launched, and nobody is using 32092 port, so I got it. So if I click on this particular link here, it opens up my web application. So that's the pod IP and the host name of this particular pod. So that's the quick demo of how a NodePort works. Now let's see, or let's understand what else is going on underneath the covers. So if you look at this picture, right, there are two objects that need to be created. One is the deployment, and the other one is a service. And from the UI, from Rancher, you just created only one workload, and those two objects are created for you. So if you want to look at the YAML files or the manifest files, what you can do is click on this menu here, and you can click on View or Edit YAML. So this pulls up the manifest file or the YAML file, and you can see, the spec for this particular part. So this is very similar to what we have here. And the other thing what Rancher does behind the scenes is it creates a service. It's called Bravo NodePort automatically when you specified, hey, create a NodePort for me, and you can see the view or edit YAML. Okay, I'm not sure. I think I'm having the demo gods are not so happy. Something is wrong, but you'll be able to see the manifest file for this particular service. Let me try it a different way, if I can show it to you. So this is how you can launch the kubectl shell, and kubectl get service. All right, cool. Kubectl get service. Let me specify the name here, and I want to see that in a YAML fashion. All right, cool. So here you can see, this is kind service here, and where is the type I'm looking for? Okay, cool. So here is the type NodePort, and you can see the NodePort 32092. All right, so that completes the demo for NodePort.
Couple quick questions,
Sure.
Murali, from Robert, who asks, if the DNS is pointed to an IP of one node in a cluster, does traffic get distributed across all the nodes with a NodePort or with Ingress?
Okay, so I'm just thinking, should I answer this question right away or should I wait for Ingress, right? Okay, I'll answer it in the context of NodePort. So if you have a CNAME pointed to a node, which is the DNS entry, and you try to access it, you are going to specify the node port. So now the node port is in the range of 30,000 to 32,000 or whatever you have configured on your cluster. That port is different from the ports used by your Ingress. So there will not be a conflict. It's very clear. If you are using a node port value when you're trying to access using the IP address, you are going to hit the node port. That's it.
Okay, sweet. One more question. Is NodePort the same as a port forward done by the command line?
I do not think so. No, it's not the same. It's a different thing.
Okay, cool. All right, yeah, why don't you keep going?
All right, so this is a different kind of a service called load balancer service, which is available in Kubernetes. Now, to be able to use this specific type of service, you need to enable an option called cloud provider when you are creating your Kubernetes cluster. Let me just quickly show that to you. When you're creating a cluster, let's say I chose EC2, you can see there is an option called cloud provider. You can, let's say if it is Amazon, you can select whether you want to enable the Amazon cloud provider. So what it means is you need to create certain roles and IAM instance profiles in your AWS account and use that profile name when you are creating the nodes of your Kubernetes cluster. So to find more information, you can go to docs.rancher.com and you can go to rancher2.x, and here I think there is a cloud provider somewhere here. Let me search. Cool, there's a cloud provider, and here I believe, yes. So here is the IAM policy. So you first create a policy, you attach to a role and use that role name when you are creating the nodes of your cluster. So for creating the node templates, you go here and let's say you add a node template, and okay, you see this particular field, you have to specify your profile name here so that you can take the cloud provider functionality into your advantage. Cool. All right, so what happens when you enable this cloud provider, right? So let's say you create this kind of a service. By the way, so this is an external load balancer. What it means is it helps you expose your application outside of your cluster. When you create a service of type load balancer, it creates a load balancer in AWS or whatever cloud provider you are using. Along with that, all the underlying components which are needed are created. For example, if a NodePort is needed, a cluster IP is needed, they're all created for you automatically. And how things work for each cloud provider, it really depends on the actual implementation. So you can check out the documentation here in this at this particular link to find out what options are available, how you can customize this particular load balancer and stuff like that. One important point to note here is when, for example, in AWS, if you create a service, it's going to create a new load balance for you. So if you have 10 different services, you are going to end up with 10 different load balancers. So you got to be really careful when you're using this service. Otherwise, your costs are going to go up. This is not like Ingress, where you'll see, you just have one load balancer and then you can create multiple Ingress objects. Here, every service object creates a new load balancer. And also, by the way, this load balancer service is also layer 4. And I think the newer versions of the load balancer controller, they are able to leverage layer 7. So you can check out the documentation for more information. They use annotations to customize your load balancer. You can pass SSL certificates and things like that. All right, so what happens behind the scenes, you have a deployment, let's call it Charlie here, and then you create a service. And here you can see line number 8, you are specifying the type of the service as a load balancer. The same old things. You can have you can see the port mappings, you can see the label selectors, and you can see the internal clients that can access your service using the service name, the port, and your external clients can access your app using either the IP address of your load balancer or the CNAME or an alias for the load balancer. All right, so for the demo of this particular type of load balancer, we are going to use the same Kubernetes cluster. We are going to launch a app, and then we are going to see it in action. And just like the other scenarios, you can try out yourself, how the upgrades are done, how scaling up, scaling down is going to work, and things like that. All right, before I jump onto the demo, are there any questions?
This is from Kishore. Is there any way to have a load balancer without a cloud provider?
Yeah. I mean, there are other options available. Like the first thing is, if you disable, if you just disable the cloud provider option, obviously then there's no load balancer created for you, and you can have load balancers in front of your cluster. There are other options, other ways you can set up load balancers. I'll cover that towards the next topic.
Okay, cool. There's many questions on various topics, but why don't you go through the demo and then we can.
Sure. Let's just go through the demo.
Yeah.
All right. So let me jump back to workloads here and switch to workloads. All right. So we are demoing type load balancer. So let's click deploy, and this is Charlie. I'm using the same image, and I'm using a single pod. And let me click on add port. I want to run my container port on 9003, and for that I specify the port as 9003, and I want to see the alphabet C. And here you can see in the drop down menu here, I can specify a layer 4 load balancer. So this option is available if your cluster has cloud provider enabled. So let's just click this, and you can specify what port you want to expose this on. And like I mentioned earlier, this particular layer 4 load balancer type is useful if you are trying to use a non-web app. What it means is, let's say you have MongoDB or MySQL or some chat application, you can use this kind of a load balancer. There is no limitation like Ingress. So let's say I want to use what was the port I was planning to use? Let me check. 93. All right, so I want to use port 93. That's it, and then I launch it. Cool. So here, while this is going through, oh cool, it went through. Let's switch to service discovery. Under the hoods, the load balancer service has been created, And if you want to get more details, before we do that, let's just click on this. Here you can see we have hooked up the CNAME of the load balancer that was allocated to us. As you can see, this is not yet loaded. The reason is, if you go back into the cluster, launch the kubectl, we just have the load balancer created just a few seconds back, and usually it takes like a minute or two for the DNS entry to propagate. As you can see, the error message, it says it failed on DNS, non-existent domain. So let's try it one more time. It's still not there. You can check this from the command line as well quickly. Now let me copy this. All right, so now it's no error. I think the page should load now. Cool, there you go. So we have a load balancer type service working in action. I want to show you, I want to explain what's happening underneath the hood, right? So when you create a load balancer service, a new load balancer is created for you. We saw that here. And under the ports column, you can see, the load balancer is exposing the port 93. Now, underneath the hood, as you know, the app that is launched inside a cluster, it cannot be accessed from outside. So you need some kind of a concept. So what happened here is, Kubernetes created a NodePort on your behalf automatically, and this NodePort is mapped to the Charlie application that we have launched. So underneath the hood, a lot of things are happening when you create a service of load balancer type. Okay, cool. So that's all I have here. Let's jump back to the next topic. All right. So this is the most interesting thing in Kubernetes. Ingress is mainly used for enabling your web applications running inside your cluster to be accessible from outside. Like I mentioned earlier, an Ingress cannot expose any kind of port. It is dedicated for web applications. What it means, it's like port 80, port 443. That's it. An Ingress is capable of load balancing, just like the other load balancing options that we saw earlier. The additional functionality that an Ingress can do, which the other apps cannot do, is SSL termination. And also, the Ingress can do name-based virtual hosting or routing. What it means is an Ingress is capable of working at layer 7. It can do a deep packet inspection, look inside the contents of your packet, look at your layer 7 or your application headers, which are your HTML or HTTP headers, and then figure out more information and can do intelligent routing. For an Ingress to work in a Kubernetes cluster, you need to have a component called Ingress controller or an equivalent. In today's topic, I'm going to focus more on the Nginx Ingress controller. That is the default Ingress controller we use when we launch an RKE cluster. There are other options available as well, like HA proxy, traffic, contour from various other companies. All right, before we jump on, I want to show you where to find this Ingress controller. So you go to the cluster and you can find this system namespace. So in the system namespace, in the system project, you have various namespaces. So here we can see Ingress-Nginx. Here we can see the Nginx Ingress controller. If I expand this, you can see there are like 3 parts, so running one part on every node. So what it means is this is launched as a daemon set. you can also tell that by looking at the small, like a global or a globe option here, which means a daemon set. Let's just confirm that. Let's view or edit YAML. All right, so here line number 2 tells me that an Nginx Ingress controller is launched as a daemon set. That means there's going to be one pod running per node, and there are other configuration options which are passed when the Ingress controller is being launched. You can upgrade this daemon set, pass your custom configurations if you want to, and here you can see the ports that are being exposed. Like I mentioned, it's by default port 80 and port 443. You can check the logs of this Ingress controller. When I remember a person asked, hey, I see a error, I cannot access my page. In that scenario, what you can do is you can come to this project, look at the logs of this Ingress controller parts, and they will probably give you a clue as to why a certain backend or a certain host is not working, or something is wrong with your Ingress configuration and stuff like that. You can find that information here. So this is a useful page for debugging Ingress related issues. And in Amazon EKS, if let's say you are using a EKS cluster, the Ingress controller is not launched by default. If you want, you need to launch it yourself. All right, so how do we use the Ingress? All right, we have the same kind of a deployment that we saw earlier, and then you have a service which is exposing the app or your deployment inside the cluster, and you create an additional object of kind Ingress, and you are going to link it. This is the same linking that we have seen earlier. The selector labels, the target ports, how the internal clients access your service. Just a recap. And here you can see how the Ingress object and the service object are linked. In the backend rules of the Ingress, you can specify what backend you are using. Here we are using the service name and what is the service port that I am interested in. So this is how the Ingress object and the service object are linked. If an external client wants to access the Ingress, what it does is it picks any of the IP addresses of the node, and it can append the path here and access the Ingress that we have just created. So this is how your app is exposed outside of your cluster using an Ingress. And as I mentioned earlier, you can expose only HTTP or HTTPS apps using Ingress. One of the questions one of the users had mentioned, hey, I see this 404 error. So what is this 404 page that we see, right? So it's basically a default backend. What it means is if you try to access the IP address of the node and there is a non-existent path, you got to show some useful page to the user saying that, hey, this page doesn't exist or something is wrong. Otherwise, the user is left clueless. So we launch something called as a default backend, which is like a catch-all entry for all the non-existing paths or incorrect domain virtual host that are configured that are not configured in the Ingress. For example, here you can see this is the default backend. It uses this particular image. For the Ingress demo, we are going to use the same Kubernetes cluster, and here we will have the same internal client part, and here you can see this gray parts, the gray and black striped boxes, which are the nodes where you have the Ingress controller running. So you can pick IP address of any of these parts and access your application. I want to show the demo before I take the questions here. So let's just go through the demo. All right, let's switch to the default project. So I already have an application called Alpha, and I just want to use that instead of trying to create a new application. So what I can do is I can create an ingress by going to the load balancing tab, and then I can click on add ingress, and I can specify what is this. So this is a alpha ingress, and specify a host name, and I can choose the workload and the port. I believe it is 91, and I can save it. It takes a few seconds for this to become active. Okay, while this is going on, let me take any questions if you guys have.
Yeah, this one is from Shivdeep. How do I create my Ingress host name not dependent on the node IP, since the node IP can change?
Sure, I'll be covering that soon, so I'll answer that question.
Okay, cool.
As we go to the next slides, yeah.
Okay, the next one is from Nathan, who asks, is there any logic in an ingress that decides which node or pod to choose when a user requests the hostname and port?
Basically, it does load balancing, right? So it does traffic distribution. So I think there are strategies that you can configure, which are available for Nginx load balancing. Like you can change them. You can have round robin or list connections and stuff like that. I think some of them are configurable, some of them are not. So there are different strategies.
Cool. Okay, one more, and this is from Kelly, who asked a while ago. So thanks for your patience, Kelly. Asked, would you recommend using Nginx or Istio for load balancing in Ingress, and why?
Okay, so at this point, I'm not going to talk about Istio. So Istio is like a topic on its own. It's we need to cover all the topics. So probably we can take the discussion offline, or we could have another talk in future where we can talk more about Istio. I think probably at that context, it is best to answer that question. At this point, I would pass on that question.
Okay, no problem. And I'll just mention that we do actually have a whole Istio class coming up in
Awesome.
June.
Yeah,
June
I think
4th,
that
so in a
would be
month.
the right
Yeah.
place to answer the question.
Yeah, cool. Okay, I don't see any others. Oh, here's one. I've set up the Ingress load balancing as per the startup instructions for Rancher, and don't actually know how to verify that it's working. How do I do that?
Oh, we'll just do that right now. How do we verify the Ingress that we just created, right? So we'll just check that. Okay, cool. So we have the load balancer working here, and let's just go to the nodes page, and we can see these are the different worker nodes. Let's pick one of these IP addresses, and from my laptop, let's just do a curl of this on port 91. Okay, did I specify the right things? All right, let's debug this guy. Let's see. Okay, let's go to the default. I like to sometimes work with kubectl. So kubectl get deployment alpha -o YAML. So here we can see this one is running on 9001. That's good. Container port 9001. The next thing is get service. Oh, sorry. All right, so we have a service. Oh, wait a second. So when I created the ingress, did I choose the right service? kubectl get ingress. All right, so that's my ingress. Oh, I got it. I think I know what I'm doing wrong. So here, like I mentioned, Ingress works with port 80 and 443. I by mistake I meant specified 91. So there you go. Curl blah blah blah, and we have a redirect. What do we have a redirect for? All right, let's look at the ingress. Okay, let me, the service name is not correct, I believe. Okay, that's 91, that's that.
Murali, a couple people are pointing out that the redirect is for HTTPS, but you're asking for HTTP. Maybe that's the issue.
I do not think so. So actually I had to specify a path. Okay, let me do this, right? So let me delete this particular ingress, and then let me delete it this way. And let me import a YAML. I have a YAML file. Okay, this should work. Let me just verify alpha. Okay, that's okay, that is correct. And now let me go to load balancing, import, and then I'm creating an ingress named alpha, blah, blah, blah. Service port is 91. Okay, cool. Still in the process of creating it. Okay, while that is going on, let's just go through the other topic, and then we can come back to this demo. So if we look at the ingress types, there are like various types of ingress. One is a simple service. So in a simple service, what happens is, it's the same thing that we just saw. You can specify a particular path, and you can use the IP address of any of the nodes running in your ingress cluster to access your application or your service. For example, if your cluster has these IP addresses from your external client, you could use any of the IP addresses and the path to access your particular application. So that's a simple service type. The next one is this is the question I think we had, like, if I point my CNAME or my DNS entry to the nodes, here you can see we are using directly the port 80. So there is no confusion between the NodePort and an Ingress. And you could use the CNAME or the DNS entry pointing to the IP addresses of your nodes, but that is not a recommended approach because you cannot rely on DNS to do load balancing for you. You need to have an actual load balancer sitting in front of the cluster, pointing to your nodes of your cluster where your Ingress controller is running, and then you point your CNAME to that, and you can access your applications using that CNAME. My recommendation is never point your DNS to the nodes directly. Always have a load balancer in front of it. And we have an Ingress type called fanout. So what it means is you use the same Ingress, and you can have different backend paths used to expose different kinds of applications. So here /alpha, it points to the alpha application, /bravo points to your Bravo application. Here is an example how you can access it in a cluster, and with a load balancer and the DNS pointed to it, you can access appsmydomain.com /alpha or /bravo. And then we'll come to the other topic, which is virtual hosting. Before we do that, let's check our load balancer. Okay, cool. So this is up, and let's switch to this page and go to the workloads. Yes. So if you see, we have the objects to access our application. Okay, so we are using the HTTPS advanced proceed. That's our application. So I have a load balancer in front of it, because of which it's doing a auto redirection. If I do it from the curl, I think we should be able to see this working. Oh, /alpha. Okay, so I have a load balancer sitting in front, which is doing this redirect for me. And then so that's /alpha. And here, if you want, you can create a simple fan out object, like you can import a YAML, or you can edit the existing YAML for the Ingress object here, and then you can add /bravo to point to your other application. So that's the demo of how you can use a path-based Ingress. The next topic in Ingress, which is of interest to many people, is how do you do virtual hosts? So let's say you have these two applications, Alpha and Bravo, and then you create two services, and you can create an Ingress object. This time, we specify a host instead of a path. What it means is, when external clients are using it, they can use HTTP alpha, whatever apps.mydomain.com. But the problem here is, how does the name resolution happen? It's not an automatic feature available on your Kubernetes cluster natively. You need to have either a controller running in your Kubernetes cluster that can do DNS name resolution for you, or you can create a CNAME or a wildcard entry in front of the cluster to expose these applications. What it means is, now let's say you have these two domains, and you have your applications running in your Kubernetes cluster. You have a load balancer sitting in front of your cluster, and you create DNS entries, alpha.apps.mydomain.com, bravo.apps.mydomain.com, point those to either the IP address of the load balancer or the CNAME of the load balancer in case if it is AWS, and then external clients, which is your laptop, can use this host name directly to access your application. So this is how the routing or virtual hosts work. The problem here is, if you are creating these CNAME entries manually, it becomes tedious. the dynamic nature of Kubernetes, could be exploited by using a concept in DNS called a wildcard entry. What it means is you just create one DNS entry. It's called star.apps.mydomain.com. What it means is you can have any prefix like alpha.apps or bravo or whatever, hello world, test.apps.mydomain.com. Now, all of these domain names hit this particular DNS entry and they get resolved, and they point to the load balancer, and this load balancer is pointing to the various nodes of the cluster, and you can access your applications. This is a wonderful way of leveraging the dynamic nature of Kubernetes. You can launch your applications, and you don't have to ask your underlying IT operators, hey, can you create this DNS entry for me? No more tickets. Just ask them for, hey, create this one wildcard entry for me, and then boom, you can launch your apps on the fly, and they just start working. So this is an amazing feature. And here I gave an example in the previous slide. I gave an example of AWS. You could use any other load balancer instead of AWS. Like you could use FI load balancer. FI has its own controller which watches the Ingress objects, and it creates rules inside the FI load balancer. For this, you don't need to have Ingress controller running. You can have something else taking care of programming this for you. And the other thing that an Ingress can do is SSL termination. So for this, what you do is very similar to what we have done in the past. You create an Ingress object, very similar to the simple service. You just have an additional section called TLS, which points to your certificate name. So you create a certificate before you create an Ingress. You upload your certificates, and then you can use that to create your Ingress objects. You instead of you can do when you create an Ingress with the TLS, you have the certificates available on all the nodes, and they can do the SSL termination for you. All right, so let's see the demo for this. So I have Alpha and Bravo. So what I want to do is create an Ingress. This is a virtual host Alpha, and then specify a host name. So I already have created. Let me see if I can pull that up. Okay, so I already have created a wildcard DNS entry. Let me show that to you. If you see dig star.apps dot, I think it's Leo dot rancher dot space. Yes, so that's the wildcard DNS entry that I have already created, and I can specify the host name alpha dot apps dot leo dot rancher dot space, and I can select a service. Let's say I can choose a service, and I can choose alpha here, and I can save this. In the same way, I could add one more Ingress v host, and then I can specify a host bravo.apps.leo.rancher.space. I hope I gave the right host name in the previous page. Okay, I did miss. Yes, I did miss this Ingress. Let me edit it. Okay, cool. So let me access this here. Okay, let me access it from the command line. Okay, so we edited the other Ingress, so probably it's taking time to update. But here you can see, I can access bravo.apps.leo.engineering.space. So we can use vhost for Ingress. So that's the demo for the virtual host routing. And the next thing that I wanted to show you quickly was the SSL termination. So you can upload your SSL certificates in Rancher. Now let's just, I have a different domain for the SSL certificates. Let me see. Okay, so I can get my private key, private certificate. So I can paste it here and I can get the certificate. Paste it here. And the name for this is basically, it's a star Leo AWS dash engineering dash rancher dash space. So that's the name of the certificate, and I save it. And now I can go back to my workloads, and here what I can do is add an ingress. This is alpha TLS, and I can specify a host name. So this is using this host name, alpha TLS, and I can choose a service alpha, and here I can specify a certificate. Choose a certificate, add a host, and I can save it. Cool. So once this is available, we should be able to access it. Cool. So here you can see I could access my application using TLS from the Ingress, and here you can see the certificate being served, which is the wildcard DNS certificate. And I have set up the wildcard entries for these two domains, like I showed in the picture here. I have my wildcard domain, so that's how I'm able to access my applications. So that's the demo for Ingress TLS. And any questions, Matthew?
There are a few. If you have more topics to go over, maybe we should do that first, and then we can just get to the questions.
I just have one quick slide that I wanted to show. A couple of slides. So basically, the main question that people ask is, hey, should I do Ingress at should I do SSL termination at the Ingress, or should I do it at the LB? This is the most frequently asked question. So the way you would do it really depends on your organization, how your networking is set up, and things like that. And if your connection between your load balancer and the nodes of your cluster, if that is secure, you can terminate your SSL on the load balancer, and then you can have the backend communication without SSL. So that's doable. But if it is not a secure channel, then do your SSL termination on the nodes itself. So that way the traffic is encrypted all the way up to your nodes. And also sometimes it depends on the policies of the organization. Some of the organizations, they have a policy that, hey, you cannot terminate SSL at the LB. The traffic has to be encrypted all the way till the nodes. So it's a policy driven thing. So it's a decision based on your business you're in. And the other thing to keep in mind is, when you create a certificate or a TLS secret in Kubernetes, it's a namespaced object. What it means is, if you are going to launch an app let's say if you have a wildcard certificate, if you want to launch your apps in different namespaces, then you got to create that secret in each of the namespace. So that's an additional overhead that you have to keep in mind if you plan to use SSL termination using Ingress. And how do you rotate the certificates and things like that. If you have the certificate at LB, rotation means you just have to leave it up to the load balancer to auto rotate the certificates. For example, if you are using AWS, or you can just update it in one place. So these are the various things that you have to think about when you are making this decision, where you do SSL termination. And the other architecture, one of the frequently asked questions is, hey, how should I architect my application for high availability, and what should I do with Ingress? So this is one of the architectures that I personally like when I'm deploying Rancher, and also when I'm deploying my workload cluster. Here I'm giving an example of AWS. You can use the same concepts in other cloud providers, or if you're using other solutions. So I set up Rancher in a HA mode. The way I do it is I create a RKE cluster using multiple availability zones of a particular region. Like you can see the different colors of the cloud here, those represent the different availability zones. And then I create 3 nodes in these 3 different AZs and create RKE cluster. On top of it, I create a Rancher. And I have a load balancer in front of these 3 nodes. And this load balancer is pointing to my 3 different nodes. Now here I have an option of doing TLS, or which is SSL termination, either at the load balancer level, or I could do it all the way up to all the way inside the RKE cluster. So like I mentioned, it really depends on your organization. Both the things work in Rancher. And you can have your domain pointed to this particular load balancer, ranchers.mydomain.com, and that's how you access Rancher. And when you create the workload cluster, what you could do is, you could launch your nodes, worker nodes, in the 3 different availability zones. And you can have multiple replicas of your etcd, like 3 if you are running in 3 AZs, or 5, it's got to be like an odd number. And then you can have multiple of your control plane nodes. And here what I've shown is the Ingress nodes. So what I have done here is, instead of running the Ingress controller pods on all the nodes of my cluster, I would create a new node template, and I use the scheduling rules to make sure the Ingress pods run only on these nodes using labels, tains, or tolerations, all sort of things. And these nodes are special nodes, like probably like much beefier than my other nodes in the cluster, which just handle only the Ingress traffic. And then I have my load balancer pointing to just these three nodes, instead of pointing them to my 100 nodes in the cluster, or 10 nodes in the cluster. I have more control on where my traffic is directed to using the load balancer. And then I have obviously my worker nodes, and using taints and tolerations, I make sure that none of my actual workloads get deployed on my Ingress nodes, or they do not get deployed on my control nodes and etcd nodes. And in front of this load balancer, I prefer to use a wildcard DNS. This gives me the flexibility to launch any application on the fly, and I can give whatever name I want. So here I just chose star.apps.mydomain.com. Let's say in your organization, you have like 2 or 3 different production clusters. Let's say, I would probably name them as, let's say, us.prod.mydomain.com for the US region. And then I have a different cluster for Europe. I would say star.eu.prod.mydomain.com, something like that. And then for my internal QA purposes, I would create a domain called star.qa.mydomain.com. That's a QA cluster for my testing purposes. And for development, I would probably use star.dev.mydomain.com. Having this kind of setup really gives you the flexibility. You don't have to keep going back and forth between IT and your network team to have your load balancers open, your DNS entries reprogrammed, open up firewall rules and stuff like that. Just have this wildcard DNS entry, and it is super powerful and super flexible. So this is one of the architectures that I would recommend for Ingress based routing and for high availability. So those are the slides that I have. Those are the topics that I wanted to cover today. I know I went a little over time, but as you can see, there are like so many topics that we had to cover, and also actually there's a lot more content that I can talk about. I had to like really choose only the most commonly used ones. So thanks for your time. And Matthew, any questions that I can answer?
Yeah, Murali, there are questions, and I so appreciate this presentation and all the work. I know you put in so much work into this, so thank you for making these slides and these demos. This is just invaluable stuff. So let's get to the questions. Let's see. This is from Basir, who asks, can you configure load balancing to Ingress to forward client certificates to the backend, i.e. in HTTP headers or for client authentication?
Okay, so if I have to repeat the question, can I use different certificates is the first thing that I could understand, and can I point them to different backends? Did I summarize it correctly?
I think so. I mean, he says, can you configure load balance?
Yeah. So the answer is yes, you can do that. You can use different hosts, different certificates. It's just a matter of how you configure your DNS entries. So in that scenario, what you would do is if you, let me see if I have a picture for that. Okay, probably this is one of my earlier slides. Okay, so this is how you would set up your Ingress. So you would have the certificates imported into your Kubernetes cluster. You create different Ingress objects, and you would have different CNAMEs pointing to the load balancer, pointing to your nodes of your cluster. So that way you can access these different domain names and your apps.
Okay, great. Let's see. Does Rancher support Let's Encrypt certificates?
I believe yes.
Okay. All right. Great. Let's see. This is from Nathan, who asks, are SSL certificates only available when using the virtual hosting on Ingress, or is it also possible with path-based Ingress?
That's an interesting question. So my understanding of certificates is you get a certificate for a domain. So let's say you have a certificate for star dot, or let's say you have a certificate for apps.mydomain.com. Now you can have that certificate and you can use that for /alpha/bravo, like apps.mydomain.com/alpha/bravo. Yes, you can use that.
Okay, sweet. All right, this next one is from Nadir, who says, which host names can specify for ingresses? Any host name or only specific ones?
I think it doesn't really matter. Like, it's so when you specify a host name, so what you're basically doing is you are telling Ingress controller, like, hey, you're doing this deep packet inspection, and then in the HTTP data, if you see this particular string, do the directed traffic to this particular backend. So Ingress is think of it like a simple a pattern matching, right? So you're matching the host that you have configured in the Ingress against the traffic that is entering your cluster. The bigger problem is now, how do you make sure that traffic is pointed towards the cluster and the traffic is reaching these nodes using those CNAMEs? So if you can point the right DNS entries in the right fashion to the LB, and that LB is pointed to the nodes of the cluster, your Ingress can handle any domain names.
Cool. Awesome. Okay. Thank you. Here's the next one from Mike. He asks, can an Ingress pass 8443 on one public static IP back to several different web apps, all on different FQDNs and in different clusters, or would that require a public static IP per cluster?
Let me pull up that question. It's a big one. So
Yeah, from Mike Paget, and we
stop
have
sharing my screen.
Sure.
And then let me open the questions.
Mm-hmm.
Would you be able to send it on chat for me?
Sure. Let's see. Okay, I just sent it to you.
Okay. Can the Ingress pass 80 and 443 on one public static IP back to several different web apps, all on different FQDNs and in different clusters? Okay. The first thing is an Ingress controller works in a single cluster. So the moment you have multiple clusters, you are dealing with a different component. So you cannot do load balancing across different clusters using a single Ingress controller. An Ingress controller is dedicated to a single cluster, and within that cluster, yes, you can do whatever web apps, different web applications. And how do you expose using a static IP? That static IP is probably pointing to your load balancer, and the load balancer is pointing to your Ingress nodes, or the static IP belongs to one node in your cluster which you have dedicated to run the Ingress controller. That is also okay. But the problem there is, let's say if that particular node dies, then there is no way you can do Ingress. Like your traffic is basically black hole. So that's why I would recommend use a load balancer, point it to multiple Ingress nodes, and use the IP of the LB to configure your different hosts.
Okay, awesome. Thank you. Here's another one. It's from Bikash, who asks, does Rancher 2.2.2 support layer 4 metal LB?
At this point, we are getting, we are seeing some traction from the community using Metal LB. So we are evaluating, our options. So if there is, enough demand, and then, based on our priorities, definitely we will consider. But at this point, I do not think we have a first-hand integration of Metal LB.
Okay, cool. Yeah, a couple other people were asking about Metal LB integration as well. So thank you.
Okay.
This is from Noah, who asks, will Rancher support other load balancers like HA proxy or Trafic in the future?
So the RKE clusters, when you deploy, by default they start with Nginx Ingress controller. The config allows you to use a different Ingress controller, so you can swap it out technically. You can disable the default Nginx Ingress controller. You can launch whatever Ingress controller you want on top of a Kubernetes cluster. So Rancher doesn't come in the way. So yes, it's kind of supported, but there is a little more work involved there.
Right. Okay. This is from Zach. Does or will Rancher provide any functionality for using F5 as a load balancer for Kubernetes apps? I tried following the install docs from F5, but couldn't get it working as desired.
The first thing is, first of all, yes, it works. I have seen it in multiple customer deployments where folks are using FI in front of the Rancher setup and it's working. So if you are having trouble, so probably you can post the question on the Rancher Slack, and hopefully somebody who has worked with FI, they can answer it. They can give you more guidance. If not, if you think there's a genuine bug, you can create a GitHub issue as well.
Cool. Okay. This is from Steve, going back to service cluster IP range. He asks, in RKE launch clusters, is the service cluster IP range automatically configured, or do we need to add that manually?
In our key clusters, we automatically pick 10.43.0.0/16 as a default service IP range, and 10.42.0.0/16 as the pod seeder range. So it's done automatically. If you want to customize it, please feel free.
Awesome. Okay, this next one is from Bikash, asking about Metal LB, although you just mentioned it, but let's see. He says, I have Metal LB installed and running, and when I go to deploy the layer 4 load balancer, it says disabled. Is it possible to enable it?
Nope. At this point, there is no, I mean, it's not like a cloud provider option. So that's why in the UI, it shows as disabled.
Got it. Okay, that makes sense.
So I have a pointer to Prakash or the other folks who are using Metal LB. Hey, it would be great if you guys can ping me on Rancher Slack. I want to get in touch with you and understand what you are trying to do with Metal LB, and then gather more information, and then I can have more discussions in-house. So it would be great if you guys can ping me on Rancher Slack.
Awesome. Okay, great. Cool. And what can you say what your Slack name is, Murali?
Leo.cloud.
Leo.cloud. Okay, terrific. All right, here's another one. This is from Nathan. He asks, does Rancher monitor the traffic or load on the load balancers or on Ingress, and is it visualized? This could be interesting for integration with scaling.
Yeah, in 2.2 or 1, I believe. So we did integrate Prometheus Grafana natively. So what it means is you go into the settings, you enable monitoring, you can access awesome dashboards where you can see all sort of graphs. You can get a lot of statistics. So yes, you can.
Okay, fantastic. Let's see. I think there's a couple more. Noah asks, I might have actually asked this question already, but just to make sure we cover it. So Noah asks, how do I use a layer 4 load balancer for an on-premise cluster?
I think what I have seen is people use FI load balancers generally for on-prem deployments, and then recently I see a lot of adoption of this Metal LB. So probably those are your options. If you can probably ping me, I can take a discussion offline and then probably help you out.
Okay, cool. Thank you. Yeah, there's a couple other people asking about that. This one's from Nader, who asks, what's the difference between Ingress and HTTP proxy?
What is the difference between Ingress and HTTP proxy? My understanding is an Ingress is basically doing the things that we just discussed about, and then HTTP proxy is basically let's say you have your nodes of your cluster, they cannot access your internet directly, so you have to go through a proxy server. So you specify the IP address of the proxy server using environment variables HTTP_proxy, all caps or R lower, and that's how you can access the internet. That's my understanding of a HTTP proxy. So these are two different things.
Perfect. Okay, great. Next one, this from Kelly, kind of follow-up question to the question about Istio. Kelly asks, will Istio interfere with Nginx? Can I have both in place?
I believe they are working at the same layer, or basically they are working in the same name, in the same space, right, on the same domain where they're trying to do service mesh, service discovery, load balancing. So I think it's possible that they can collide. I haven't tried it myself, so I do not know. You could try it out and then you can see if it works or if it doesn't. and you can let us know.
Okay, terrific. Here's another one from James Goodwin. Does Rancher support F5 external load balancers that are hosted on-prem in a private data center?
Yeah. Like I mentioned earlier, I've seen it personally at a lot of our customer deployments. The F5 is used. It's quite a popular load balancer for on-prem.
Terrific. Okay. Here's another one. Here's one from James, who asks, and I think there's just a couple more questions, Murali. So thank you for going through these.
Sure, no worries.
Awesome. So James asks, is NodePort load balancing capable of managing persistent TCP connections between external clients and pods behind the NodePort service? If so, how does that work?
Okay, persistent TCP connections. That is an interesting question. So basically, my understanding of a persistent connection is, you have a certain source IP targeted to a certain target IP, and I do not have an answer on top of my head. We need to look up the documentation, see, how the load balancing is done, and are there any specific types that would help in persistent connections like this. So at this point, I do not know on top of my head.
Okay, no problem. All right, let's see. Okay, here's one. Am I right that the load balancing with cluster IP is different to the rolling update on pod deployments? It seems really similar, but maybe rolling updates add more pods while the old ones are updating. Is that correct?
So the rolling update, it's more about how the updates are being done. The load balancer is basically, how it can handle any scenario, right? Like, during updates, whether it's a different strategy where you terminate the pods first and then launch the new ones, or you start replacing one after the other. All sort of upgrade strategies are supported by LB. I'm not sure if I answered the question, but yeah.
Okay, no problem. Okay, here's one from Andrew, who asks, do you know of any cluster DNS service that will register cluster resources with external DNS?
Can you repeat that? Do you have any?
Yeah, he says, do you know of any cluster DNS service that will register cluster resources with external DNS?
I believe if you look at the Helm charts, there are a few controllers which are available. Yes. Like I said, I do not know on top of my head, but yes, there are some options available.
Okay, fantastic. That was the last question. So I think I got all in. So I am going to go ahead and just make myself the presenter and show these last slides just to close us out here.
Okay.
Make sure, let me know if you can see.
Yeah, I can see
this. Okay, cool. So for everybody who's just new to Rancher, it's totally open source and free, and you can get started in just a couple steps. If you go to rancher.com and click the deploy button, it'll bring you to this quick start, and you can follow these steps, or go to the quick start guide and see how to get an HA setup going. But it is totally free and really easy to use. We also do intro training for Rancher and Kubernetes on Thursday, always free. It's every Thursday, so go to that and return. As I mentioned, Rancher is enterprise container management software. It's great for DevOps, making life easier with CI/CD and our app catalog and monitoring and logging, and this great UI while retaining API access, as Murali has shown, and also tons of great features for operations, for security and policy and authentication. So if you do want to know more about Rancher, please check out those Thursday training sessions. And as I said, this is the URL, so it's just really easy to find, and our documentation is just fantastic. Our engineers and field engineers have done a wonderful job just being very thorough here. We do a lot of other, open source products and projects. We recently launched K3 OS and K3S. It's lightweight Kubernetes distributions and operating system, and Submariner on networking between clusters. So there's a lot of cool stuff going on. So please check out, our GitHub for all those repos. And as we stated at the beginning, these slides and this recording will be sent to you all via email after the session. In addition, the registration page that you used to access the presentation or the session will be turned into sort of a host for the recording and the slides. So you should have easy access to them. If for whatever reason you can't find them, please tweet us, reach out to us. We will definitely get you set up. This is for everybody. And we have these classes pretty much every Tuesday on different topics. So next week, as I mentioned, Wizards of the Coast will be coming in and giving us a rundown on their production setup. So it should be super cool to hear from them. And Murali, so tons of people in the chat have been saying, thank you so much for this presentation. So thank you, everybody. We do have a survey at the end, so if you're able to do that, just takes a couple minutes, and we can improve our training and get new topics on the calendar. Any last messages for us, Murali, before we close?
Thank you for attending this webinar. It's been my pleasure to share my experience with all of you.
Awesome. All right, everybody, have a great rest of your week. Talk to you soon.
Have a nice one. Bye-bye.